In my previous video, I created a circuit like this. This 1x input connected up to a Nand gate and gave me the output of x and x not. Let's create that circuit. First thing I do is I put an AND gate on here, and then I convert this to a NAND gate, like so. Move it here and up a bit. Next, I put a switch here and an LED there. Let's reposition everything like so. Now let's wire it up. Bada bing, bada bang, bada boom. Our NAND gate circuit is complete. We then said that the output of this was x and x not. We then showed in our previous video that x and x not yielded, upon application of DeMorgans Theorem, x not or x not, which yielded x not times 1 or 1, which yielded, let me move this up a bit, which yielded x not and 1, and finally, ultimately, x not. That's what we did in the previous video, DeMorgans Theorem 001. Now, I want to implement this gate. I want to see what the implications are of having an x input in this circuit, and then in the end having an x not as an output. Is this circuit actually the NAND gate implementation of an inverter gate? Is it? Which is what it appears to be. Let's put this to the test. So I've got my NAND gate circuit created. I now require another circuit, my inverter, another LED, and that's all I need. I'll put this here and this here, and now I'm going to hook them up. I'll go to the input here, connect these guys together, and I'll connect the output of the inverter to the input of the LED. Now, let's move this back a bit. Wonderful. So here we can see an inverter circuit and a separate NAND circuit with a single energy source. Let's run this circuit now. I turn it on, and the power is at 0. Both lights go on. At 0, power goes in, down to the inverter. The 0 becomes a 1, the light goes on. Here to the other circuit, the 0 goes into both inputs of the AND gate. The AND gate turns the two input zeros into a 0 output. The inverter at the end, the bubble at the end, inverts it to a 1, the lights go on. Now I'm going to turn the switch on to a logic 1. The lights go off, both of them. The logic 1 goes to both inputs of the AND gate. The AND gate makes it a 1, it gets inverted to a 0, and the lights go off. Then the logic 1 travels down to the inverter gate. The 1 is inverted to a 0, and the lights go off. These two circuits are identical. Their behavior is identical, which means the circuits are identical. Here is an inverter gate, and here is the NAND gate technology implementation of the inverter gate. There is an excellent introductory video series on logic gate devices at a remarkably low sale price on udemy.com. And if you go, and this is the product right here. 16 video series. 16 videos on digital logic gates. And if you go there and you key in the discount coupon of off by 90, you'll get an amazingly low price. Don't lose this chance. And one of the coolest things about this site is if you have any questions concerning the course material that you're watching, ask a question right there, and I will personally get right back to you. Good? I wish you a lot of luck. Bye-bye now.